hey, here's the landmark and it's going to automatically perform that correction? Or is that completely custom code that you need to come in and write so that it adjusts that field of view? What does it look like for an engineer to step into that environment, and how easy it is to make that link between vision, arm, and ultimately the, I want to say, like, rough positioning of the AMR?
I could talk at length on the stationary robot aspect of that because we did that for many years. You just have, I think it's called eye in hand, but you take your pictures with the stationary robot and do corrections based on, say, a nest moving or what have you. And the tools with respect to that are going to be the same as if you parked and then ran all the tools. Like, you're treating a robot like now it's stationary because we're not going to be driving and manipulating at the same time. I'm sure there are cases where we'd want to do that, but really it doesn't make sense to me to
Sure.
be both driving and trying to manipulate, unless maybe you're like trying to stir your coffee while you're going back to the office. But, doing a correction after you've parked is going to look to me the same in the vision system as if you were just stationary to begin with. And you're going to correct for wherever you find the thing that you're looking for in the image. You're going to perform a correction with where is that tool in space and where I'm seeing this landmark versus where the robot's base coordinate system is 0, 0. So that's almost always going to have not just like an XYZ shift with it, but also an orientation shift. So it's not going to be at exactly the same angle unless you're really lucky and you've parked like perfectly parallel to your conveyor or like a list of stars aligning. That usually doesn't happen. So you've got not just like XYZ in space, but if you've got your right hand rule, how is this coordinate frame oriented with respect to your base system? I'm doing a left hand rule because I only have two hands, but I have a base coordinate system and some other coordinate system that is offset and twisted. The camera can see, like a 2D camera can see three portions of that. Like I can see XY. I don't know how deep I am without doing other calculations, which is going to be a Z height, but I can get where am I and a Z rotation. And a lot of times what I'm doing is looking at a conveyor. So that's all I really need is the conveyor height shouldn't change on me unless I'm dealing with a slanted conveyor. So I keep my Z height fixed and I say, where is my X and Y? And how far away is that? And a lot of robots have functions built in for doing that. So an example with universal robots is they have a pose trans function. So you would say this coordinate is the one that I'm caring about, and this is the one that I'm transforming it to. If I have a camera system that's away from the base, that I'm saying I'm transforming this point into the coordinate system of that camera point. You don't have to do, I think it's like a page worth of math for doing all of those offsets. The function will actually just spit out a new coordinate at you and say, if you're going to go to coordinate with respect to this system, then just go to this coordinate. And if you're going to do something with a mobile robot, that's where I'd actually say, now I get to be an integrator and say you want to have an integrator come do that, because there's not a lot of companies I'm aware of that have made software that not only tie in the correction of the position of the thing with respect to the arm, but also to tell the AMR to go park in a specific location.
Mhm.
So that's something in a UR cap or like a driver that we install that we've developed called Yugo. Our company Robe Solutions developed that. So you can actually tell the AMR which positions to remember and then create tasks. So you say, I want the AMR to go to this position and then call this robot program.